Welcome to today's Explainer. We're taking some pretty dry engineering data and turning it into a clear, straightforward framework to help you master a surprisingly complex topic. Today, we're totally reframing a massive pain point in infrastructure construction, the underlying logic of material costs. You know, for anyone who's been involved in large-scale engineering, choosing a cable tray material probably just looks like a boring little line item on a massive procurement list. But actually, behind that seemingly simple choice hides a massive financial trap as well as some serious engineering strategy. So let's just dive right into it.
Imagine you are auditing a procurement order for a multi-million-dollar infrastructure project. You've got two main choices right in front of you, a standard galvanized steel cable tray or a stainless steel one. Instantly, a totally shocking number jumps out at you. The stainless steel option is literally 2 to 4 times the price of the galvanized steel. I mean, that really makes you wonder, right? Why would any sane engineer or project manager authorize paying such a massive premium just for stainless steel? At first glance, it looks like a complete waste of the project budget. But hold on, the answer really isn't that simple.
To figure out this mystery, here is our roadmap for today's Explainer. First, same strength, huge price cap. Second, protection mechanisms and field failure. Third, the lifecycle cost showdown. Fourth, the 8 environment selection matrix. And finally, number 5, the impact of tray type.
Section 1. Same strength, different price. Now, in budget meetings, procurement teams will almost always throw out this extremely persuasive argument. On day one out of the factory, the structural integrity of both materials is completely identical. So why pay more for the exact same thing?
What's really interesting here is that under strict engineering standards, it doesn't actually matter which one you pick. According to the International IEC 6157 testing standard, both galvanized and stainless steel perfectly meet the exact same load class. On the very first day of project handover, their load capacity, their hardness, their structural support, it's all exactly the same. So on paper, it's a dead tie.
But I really want us to focus on this specific thought. The truth about engineering is usually hidden over the long haul. As the source data points out, the difference isn't day one strength, it's where each material starts failing first and what the replacement cost is when it arrives. This is a total paradigm shift. We absolutely have to take our eyes off that tempting initial purchase price and face the unavoidable reality of field degradation.
Section 2. Protection and failure. Let's look at what actually happens once these materials leave the pristine factory and enter the harsh, real-world construction site.
Take a look at this timeline. It vividly contrasts the reality of day 1 versus day 1000. On day 1, they're running neck and neck. But by the midlife point, well, this is the kicker. Galvanized steel completely relies on its surface coating to protect the steel inside. During field installation, if it gets cut or scratched or exposed to a corrosive environment, that protective layer is compromised. Once that zinc coating surrenders to wear and tear, the steel underneath quickly rusts and degrades. Fast forward to the long-term phase, and the stainless steel is still going strong thanks to its inherent material properties, while the galvanized tray has reached a critical point where it simply must be replaced.
Section 3. Lifecycle cost showdown. This is the core financial reframing of our explainer today. We're translating that physical wear and tear into actual financial profit and loss.
Okay, this is where the financial data totally flips. If you're only looking at the initial cost, that hefty premium for stainless steel is definitely intimidating. But watch what happens when we calculate the total cost of ownership, or TCO, by factoring in replacement costs. The situation reverses instantly. The moment galvanized steel has to be ripped out, repurchased, and reinstalled, its total cost skyrockets and overtakes stainless. So exactly when is stainless steel more cost-effective? Right at that tipping point of first replacement. By stretching our timeline out, we see that in challenging environments, paying that 2 to 4 times upfront premium is actually a massive long-term cost-saving measure.
Section 4. The 8 environment matrix. Now that we understand the math behind the lifecycle cost, we know not every single project requires stainless steel. We need a concrete framework to make the right call.
This is a super practical matrix that breaks down site conditions into 8 distinct environments. On the friendly side, you have dry indoor spaces, and then it scales all the way up to extreme coastal environments and heavy washdown areas that need high-frequency cleaning. With this matrix, you can clearly see the exact boundaries of where galvanized steel works perfectly fine, and where stepping up to stainless isn't just an engineering code requirement, but absolutely the smartest economic choice you can make.
The solid engineering data and matrix we're referencing today comes from a manufacturer called Xinma. They are a major player producing cable tray systems, bus bars, and smart cable management solutions for data centers, rail transit, industrial plants, and commercial buildings. And what's crucial here is that Xinma's products comply with global standards like IEC 61537, NEMA VE1, BSEN 50085, and GB 31251. Having manufacturing experience across all these strict sectors and global standards gives us incredibly neutral, authoritative data to back up this whole lifecycle cost analysis.
Section 5. Impact of tray type. Beyond just the environment, the actual physical shape of the tray itself is going to heavily influence your material decision.
Let's walk through how this evolves. You aren't just picking a material, you're picking a form. Whether you go with a ladder, a perforated tray, or a solid bottom tray, each shape introduces entirely different vulnerabilities. For instance, a solid bottom tray is way more likely to pool water or collect corrosive substances, which drastically speeds up the destruction of a galvanized coating. On the flip side, a ladder type gets great ventilation, but if it's subjected to a lot of physical friction, that coating is still at risk of scraping off. The physical form of the tray directly changes its degradation risk, which ultimately tips the scales on whether you should buy galvanized or stainless.
All right, let's quickly summarize the absolutely crucial takeaways from today. We want facility engineers and project managers to feel totally empowered to justify life cycle purchasing decisions. Number 1, always shift your focus from the initial purchase price to the total cost of ownership. Number 2, make sure you're anticipating and budgeting for the massive hidden costs of field failure and replacement. And number 3, don't just guess on materials. Use the 8-condition matrix to make a scientifically sound procurement choice.
And that brings us to our final and maybe most important question for today. The next time you're staring down the procurement list for a major project, ask yourself, are you just buying for day one of the handover, or are you buying for a decades-long life cycle? Make the smart choice. Sometimes spending a little more upfront is the only way to generate massive long-term savings. Thanks for joining us for this explainer, and we'll catch you next time.